guys, so today we're going to do Unit 2, Lesson 16. So it's still elimination. We're just adding one more step to it. So we're going to learn how we can multiply equations and change the equation so that we can use elimination without changing the actual value of it. So I want you to look at x plus 5 equals 11 and figure out what x is. All right, so hopefully most of you figured out that if I subtract 5 from both sides, then x equals 6, because 11 minus 5 is 6. So I want you to see what happens if you multiply the entire equation by 2. So x plus 5 equals 11, and go ahead and multiply that by 2. What do you get? All right, so you should, 2 times x is 2x, 2 times 5 is 10, 2 times 11 is 22. Then subtract 10 from both sides. Bring down your 2x. 10 minus 10 cancel out. 22 minus 10 is 12. Divide both sides by 2. And x equals 6. Okay. What happens if I multiply the equation by -3? Okay. So let's do that. So -3 times x is -3x. -3 times 5 is -15. -3 times 11 is -33. Okay, so then I just have to solve for x. So let's add 15 to both sides. Bring down your -3x. Those cancel out, and it equals -18. Divide both sides by -3, and x equals 6. All right. So I got 6 the first time, 6 the second time, and 6 the third time. What do you think will happen if I multiply the equation by 5? What will x be equal to? All right. So hopefully, if you guessed it would be equal to 6, you would be correct. So looking at this, we didn't ever change this equation. We just multiplied it by a factor. So when you multiply the entire equation by a value, it doesn't change the outcome. It just scales it up or scales it down. So if we multiply this equation by -1/2, we're still going to get 6. If we multiply it by -1/3 or 1,000,000, we're still going to get x equals 6, because we're not changing the value of what the equation is worth. We're just scaling it up or down. So this helps us when we are solving systems of equations, because if you look at this equation, to solve it using elimination, we would have to make sure that the number in front of x is the same or the number in front of y. So when we have two equations that are not the same coefficient in front of x or y, we can multiply those equations by something. So here she's starting out with 4x plus y equals 1 and x plus 2y equals 9. So to start solving this equation, Elena took equation B and she multiplied it by 4. Okay, so this second equation, I can multiply it by 4, so that 4 times x gives you 4x, 4 times 2y becomes 8y, and 4 times 9 becomes 36. So that's where this second equation that I just put in a box came from, and the first equation stayed the same. Now I can use the process of elimination. So from there, she subtracted the two equations. So here we've got 4x minus 4x cancel out. 1 minus 8 is -7y, and 1 minus 36 is -35. Okay, so that helped us change a system that we couldn't use elimination with to one that we could. So from there, you just continue solving for y. So we're going to divide both sides by -7. And so y equals +5. Once you get y equals 5, we still have to solve for x and figure out what that value is. Since we multiplied this equation by 4, it still does not matter if we plug it in. So you can take this 5 and plug it into either of the original equations or the new equation that you changed, and you're going to get the same value for x. So you want to pick the one that's the easiest to plug it in. So the original x plus 2y equals 9 would be the easiest because x is already a factor of 1, or it has coefficient of 1. So x plus 2y equals 9. And so instead of y, I'm going to put 5. Okay, and then just solve for x. So x, 2 times 5 is 10. Subtract 10 from both sides. Bring down your x. 10 minus 10 cancel out, and 9 minus 10 is negative 1. So your step 3, your final answer, is going to be negative 1, comma 5. So that's the ordered pair where those two lines are going to cross for us. So what we did there, we just created an equivalent system so that we had two original equations. We changed one to where we could use elimination, and that created an equivalent system that had the exact same solution as before. What if we didn't want to solve for y first and we wanted to solve for x first? Well, we could do that. Oops, let me go back. Okay, so if we wanted to do that, instead of multiplying that equation, let's see, I'll just make a new screen here. So instead of multiplying this one by 4 so that we could cancel out the x's, we could multiply this first one by 2 so that we could eliminate the y values. If we solve that, we're going to get the same answer as before. We would have 2 times 4x would give us 8x. 2 times y is 2y. And 2 times 1 equals 2. And we have the same second equation, x plus 2y equals 9. So from there, I would still subtract because I have 2y and a positive 2y. So to cancel them out, I would do subtraction. So 8x minus 1x is 7x. 2 minus 2 cancel out. And 2 minus 9 gives us negative 7. So then we would divide both sides by 7, and x would equal negative 1. So we still get that same value for x. If you plug that back in, we would have x plus 2y equals 9. So negative 1 plus 2y equals 9. Add that. You get 2y equals 10, divide by 2, and y equals 5. So we still got the same outcome, negative 1, 5. So it really is up to you which one you want to multiply by some number to get the same value in front of either x or the same value in front of y. So you can choose which one you want to eliminate first. All right, something else. If we're looking at an equation and say one of them you just can't multiply by to equal something in the other one, it's okay to multiply one equation by, say, negative 3, and then the other equation by 6 to cancel out a variable. All right, so let's look at one that is like that. So I have a couple here that we're going to kind of go through. So we have number 4. If you're looking at that, neither my x's are the same or my y's, and I can't multiply the top one by anything to get what's on the bottom. I can't multiply this one to get anything that's on the top, but I can multiply the top one by 3. And I can multiply the bottom one by 2 and get values that are the same. And that is what you're looking for there is the least common multiple. So between 4 and 6. So our multiples, in case you don't remember, are like 4, 8, 12, 16, 6, 12, 18. And so you can see that the smallest numbers that go both 6 and 4 is 12. Okay, so that's why I can multiply 4 by 3 and 6 by 2 to get 12. So let's finish that equation. 7y equals negative 20. So now I'm having to multiply both equations by some factor. Okay, and our outcome here to get our new equation, 3 times 4x is 12x. 3 times 5y is 15y. And 3 times 6 equals 18. And then in the bottom, I have 2 times 6 gives me 12x. 2 times negative 7 is negative 14. And 2 times negative 20 is negative 4. All right, so from here, I can do subtraction. So since 12 and 12 are both positive, I want to subtract them to cancel them out. So 12x minus 12x cancel out. 15 minus negative 14. So when you subtract a negative, it's the same as adding. So I'm actually adding 15 and 14. 5, 9, y. And then 18 minus negative 40 gives you a positive 58. All right, so from there, we can divide both sides by 29. And y equals 2. Not 2.5. And then from here, we know y is 2. So I can plug it into any of the original equations or the new equations that I've made. And so when I plug that into the new equation, we would have, I'll just go here. So this was step 1. And here's step 2. So let's see, let's do 4x plus 5y equals 6. So I'm going to plug 2 in for y. Five times 2 is 10. Still equals 6. Subtract 10 from both sides. And 4x equals negative 4. And divide both sides by 4, and x equals negative 1. So our solution for step 3, where you always write your answers in order of parent, is negative 1, 2. All right, so let's try one more. Let's do number 6. So for this one, go ahead and see if you can work out number 6 by yourself. All right. All right, so for number 6, your first step, you could have done a couple of different things. The easiest thing to do is to multiply the second equation by 3 so that we get 3x, and we can cancel that out. So 3 times x is 3x, 3 times 3y is 9y, and 3 times negative 10 is negative 30. And then our top equation doesn't change. It's still 3x minus 4y equals negative 4. Okay. So from here, we have 3x and 3x that are both positive. So we would have to subtract them to cancel them out. So 3x minus 3x cancel out. Negative 4 minus 9 makes you go more positive. So it's, or more negative, I'm sorry. So it's negative 13y. And then negative 4 minus negative 30 is 26. Because subtracting a negative is the same as adding. It's called a subtrahend, so there's a fun fact of the day. So from here, we're going to 5 by negative 13. And y equals negative 2. All right, so y is negative 2. Then we have to plug that back into either one of the equations. The easiest one is probably the one where x is already a 1. So x plus 3y equals negative 10. So instead of y, I'm going to put negative 10. Or negative 2, sorry, not negative 10. Let me say that. And so then we can multiply 3 times negative 2 is negative 6. So x minus 6 equals negative 10. Add 6 to both sides. And x equals negative 4. So our solution is negative 4, comma, negative 2. All right, so hopefully you feel a little more confident in this. The only new thing we added today was having to multiply one of the equations by some factor to make them equal. So your goal is to make the x's have the same number. So that coefficient in front of x has to be the same for you to eliminate. Or you can make the same number in front of y. It doesn't matter which one you do first, as long as you multiply the entire equation by some number, your answer and your outcome will be the same. All right. So hopefully this helps. And if you're still confused, get on our Google Meet on Thursday from 2:30 to 3. All right. Have a great day.